Hi everyone, welcome to week 3 of machine learning. This week we're going to start the first part of linear classifiers. But before we do that, let's go back and recap what we studied last week and look at the learning objectives for this week. So in week 2, we covered naive Bayes and KNN, two very important machine learning paradigms. Naive Bayes was the case of using a Bayesian approach to doing machine learning. There's a lot more that we're not going to cover in this course, but just to introduce you to the concept. The important thing about Bayesian method of learning is it caters for uncertainty using a probabilistic framework. We also studied KNN. KNN is the other methodology that's an instance-based non-parametric learner that is an analogizer. Basically, the idea is that we take the votes from the k nearest neighbors to determine the classification of the individual test instance. We saw that larger k creates a smoother decision surface by smoothing out the irregularities caused by outliers or dots on the decision boundary that are making the decision boundary non-smooth. We saw that there are difficult problems when we extend it to high dimensionality data. For naive Bayes, we also studied this particular problem of smoothing, which caters for the case where you don't have enough data. And we talked about a little bit about what the priors represent and how we might want to engineer a prior to cater for the likelihood of certain classes of unseen data. Now let's talk about the learning outcomes for this week. We're going to describe the basic idea of what it means to do linear classification. And in particular, we're going to try to understand one of the basic linear algorithms' conceptual idea about how to do classification in an iterative manner. That's going to be the perceptron learning algorithm, or PLA for short. In the pre-notebook, you're going to apply PLA on real examples and then also modify it to cache intermediate results, resulting in a new version called the pocket variant. In the post-notebook, we'll look at the mathematical proof why PLA is guaranteed to converge when the dataset is linearly separable. And we're going to cover related concepts relevant to machine learning in general, which is the concept of cost functions, the noisy target, and nonlinear mappings.